Okay, here we go. We are recording. What I wanted to do is I wanted to go through this example, this project here. I'm going to go through that with you, and I've got it downloaded. I've downloaded the zip. And here it is. It's called Chap 4. I'll just expand that.
What the fuck?
Okay, I guess I'm going to have to turn off somebody's mic. Okay? Everybody can hear you, so please watch your language. Okay, so let's take a look at some of these examples from chapter 4. About chars. One of your problems in your assignment actually dealt with this, different ways that you can specify a char value. A char is actually a numeric type, so you can actually assign a number to a char variable. And what we're going to do here is just output a couple of lines of code. So let's see what the output is. Your objective in these examples is always to try to see why they run the way they do. So they are the same. CH1 and CH2 are the same because the ASCII code for A is 65 and 41 in hexadecimal. 4 times 64 plus 1 is 65. So this is also the letter A. That works out to 65 as well. So those are all different ways of getting the letter A into a char variable. And this is perhaps surprising, but you can do a little bit of arithmetic with a char variable. Like you can add on to the value of a char variable, and that converts it to the next letter in the ASCII table, which is also the next letter in the alphabet if you're working with an alphabet letter. So the output we get here is 65, 66, B, of course, for adding on to the A, CH1 variable. Add 1 onto that with plus plus, we get 66, which is B, capital B. And then A is the lowercase alphabet starts at 97 in the ASCII table. So if you single quote A, remember chars are in single quotes, strings are in double quotes. So you single quote that and add 3, you actually get 97 plus 3, which is 100. Okay, now I'm going to move on to the next one. If you have any questions about that one, please feel free to ask. You can just unmute yourself and ask a question.
Quick question. So for Unicode and hex values, do you have a specific Java doc or anything that you recommend to get those particular values in direct?
I don't know what you mean. I'm sorry.
For example, for Unicode, you have \U0041. You know, I have a couple that I use, which is like \U00A and then so forward. Is there a particular like place that you can find these exact values with their results?
Oh, well, sure. If you're less than 128, you'll see it in an ASCII code table. But if you wanted to look up anything else, you could go to the unicode.org and look up the code charts.
Okay.
If you've ever done that or not, but if you go to unicode.org and look up the code charts, you can look up symbols for all of the languages on the planet, which is what Unicode was developed for. It's a 16-bit code, so you're good for 65,000 different individual characters.
Gotcha.
Yeah, it's actually quite interesting to go there. I'm going to digress for just a moment and go there. If I go to unicode.org, and if I search for the code charts in there, they changed this a little bit somewhere in here.
Whenever you get a minute, can you go over the chars again? I was having a bit of an audio problem setting up. I have to watch from my computer screen and get the audio from my phone.
Okay, you joined the wrong way. You should have joined using computer audio. I suggest you leave and come back in, but join by using computer audio.
Oh, I did. I'll leave and join again, but I did choose the computer audio. This is not giving me any sort of option to be able to hear you through my computer speakers for some reason.
Make sure your default audio on your computer is set to the correct device.
Yeah, exactly. Use your whatever sound card you've got. You want to make sure you set up your sound for that. That could be the problem. Anyway, here's these Unicode code charts. Look at this. These are all the languages on the planet. Unbelievable how many languages that we have on the planet. No wonder we have trouble getting along. We can't understand each other. Well, take a look at, for example, here's a language. These are South Asian ones. Here's one called, looks like Kalthi or Kathi. And these are the symbols in that language. And here's the Unicode values for them here. Yeah.
That's really cool.
It is. It's way beyond ASCII, right?
Yeah. The way I used to do it is I would create a for loop, go through the values of some inner classes, and then try to like list them all out in the console.
Yeah, well, that could work too. That could work. Okay. Let's get back to this. The person is having trouble with the audio there. I don't know what I could do for you, honestly. You can see the screen?
Yes, I'm just running the screen in my browser and the audio through my phone. So, but it's in sync, so it's fine.
Oh, okay, good. That's good. All right. Let's look at this next one then. It's called chars 2. Character class, capital C character class. You know that's a class because it starts with an uppercase letter. So once again, we're going to create a couple of chars in different ways, but then we're going to use some of the methods of the character class. These you could find, the ones that we're using here are all test methods that you can tell by the name of the method here is digit, for example. When you see a method with a name like that, you know it returns a Boolean. It's going to return either true or false. And these methods are all what are called static methods, so they belong to the character class. So when we want to use these methods, we have to actually write in character dot and then the method that we want to use. You can see these on page 128 in your textbook. Check that out. But you can test characters for all sorts of things, whether they're digits, letters, whether they're alphanumerics, etc. Punctuation, you can test the character for a lot of different values. The character class. And
for these, can you also do try and catch?
Well,
or is that too far?
Well, yeah, we haven't covered that yet. We don't do that until chapter 12.
Yeah, I'm just curious because when it comes to Booleans, I'm curious of like the cost effectiveness of each one. Because try and catch, when you're throwing an exception, you're creating multiple classes, aren't you?
No. When you're throwing an exception, and you're trying to prevent the red screen of death from showing up for your customers. That's why you would code exceptions in your classes. Yeah.
Gotcha.
Yeah. No. This is what we're doing here is just we're looking at methods of the character class, and because ch1 to the value of capital B, that is not a digit, so that's going to return false. Now you can see all of these in your textbook on page 128. I'll just pop over there for a sec. These are character testing methods. Here they are here. You can test them for upper or lowercase. You can change them to upper or lowercase with the 2. So you've got a lot of things that you can do with individual characters with the character class. But notice how they're used. They're always using with the name of the class first here, character dot, and then the method name. That's because these are static methods. Now, I know that doesn't mean much right now, but it will in the future. Okay. So I don't think we ran this one. We'll just run it, see what we get. And we did get a B. Notice we changed it to lowercase here, to lowercase. So instead of an uppercase B, we got a lowercase b. Pretty straightforward, I think, that one. Let's take a look at format print. This is very important. We want you to get real good at using printf. Print line will print whatever you put inside of it. Printf is better for complete control over every space in the output. The way printf works is you use a format string. Starts off with a format string. This is the format string in this case. And then after the format string, you specify the values that you want to pop into every place where you have a percent format specifier. %s, that means a string should go in this location. Percent, and now in this case, %.2f means we should be displaying a floating point number here with 2 decimal places. This is for an integer. %d is for an integer. Okay, so we have 3 format specifiers. That means we need 3 items after the comma after the format string. So that's the way it works. So the hours, when do we run this? Let's see what the output is here. Okay, yeah, the name here is Annabelle. %s name gets loaded into that spot. So we replace %s with Annabelle. We replace this with the 61250, which is the multiplication of hours times wages. And then %d was just the hours. That's the 35 hours that we had up here. See how that works? Very, very important concept using printf. Now, the way I always get that, by the way, is I just use the short form. As you know, SYSO in all lowercase and control spacebar will give you print line. Nice little shortcut. Hope you folks knew about that. If not, there it is. Now, if you want to get printf, just backspace out the ln, and you're ready to go with printf. You could make a template for it, but I don't think it's necessary. It's not that big a deal. Okay. Now let's see what else we've got here. Char grade equals A, int score equals 90. Here's another printf. A score of, now if you want to output a percent, you actually have to put 2% inside of the string. If you want to output a percent symbol. And to output a character, a char, %c is the format specifier. Now you can learn all about these again in the ebook under formatting. Let's see if we can find it here. I'm not sure exactly what page it's on, but it's right near the end of chapter 4. Formatting console output starts on page 145. I'm just going to pop down there for a second in the ebook to show you what I'm talking about. And there's where it starts, formatting console output. And on the next page, here is a very important table. If you want to output a Boolean, like true or false, it's %b. %c for a character, %d for a decimal. That just means a base 10 number. %f for floating point, and if you want to show decimal places on floating point, you put a point in front of it. %e if you wanted to use scientific notation. %s for a string. There are actually a few more as well, by the way. If you wanted to output hexadecimal, you could use %x. Okay, so that's an important table right there. And following that, there are some other pretty good examples over here. You can also specify the field width when you use printf. The field width simply means how wide a column do you want to generate the output in. So if we had, for example, %5c, that means print the character and add 4 spaces before it. In other words, print the character in a column 5 characters wide. Here's one that's very important, 10.2f. That means print a floating point number with 2 decimal places in a column 10 characters wide. So what that would actually do, it would print 7 digits, a decimal point, and then 2 more digits for a total of 10. So it's important to know how these work. And we're going to see an example coming up in a minute. And actually, that's what this one's all about right here. Take a look at how this one ends. If you want to get nicely formatted columns, you can do that with a number for the field width, decimal point, and then how many decimal places you want. So as you can see here, we get a really nicely laid out table showing very nicely formatted columns. Okay. Up here, this line here, we just generated this line of output here. So if you want control of your columns, format works great. We'll actually see something much nicer than this when we take a look at chapter 5 in a moment or two. Random integers, extremely important. In order to get random integers, we have to use the math class. You see that capital M? That lets you know it's a class. And there is a method in the math class, the random method. It'll give you a number from 0 to almost 1. You never get actually 1. You can think of it this way. You won't actually ever get to the 1. So that'll give you a decimal number between 0 and 1. If you want to show that with 6 decimal places, you could by using printf. We could also multiply it by 10. So if we multiply it by 10, that'll be a number between 0 and 9. Actually, between 0 and almost 10. It could be from 0 to 9.999, this number up here. Okay, because we're multiplying it by 10. Well, very often what we want to get is random integers. So what we have to do is we have to cast. We have to put int in front of, inside parentheses. That's called casting. That changes the double into an int. And if we do that here, it'll give us a number from 0 to 9. We won't ever get to the 10 because remember, we never get to 1 with math.random. So if you do want to get a particular value, like if you wanted to get from 1 to 10, you would have to add 1 onto this. You could add 1 on at the end like this. That would give you numbers from 1 to 10. Here's an example. If you want to get integers that go from 15 to 25, well, you have to start with 15 and then add from 0 to 10. Times 11 will give you from 0 to 10. Okay, so we'll just output this one, see what we get. Yeah, every time you run it, of course, we're going to get different values because we're generating random numbers here. Okay with that one? We're going to do this a lot where you have to generate random integers like this, or random integers in a range like this. That'll come up a lot in this course. No questions? Everybody's good with that?
One question.
Go ahead.
So for printf, do you recommend using it that way rather than kind of creating your own space control?
Your own space control? What would that be?
Yeah. So for example,
it sounds like the President's Space Force.
kind of like it's essentially when you're trying to create a chart, you're generating the spaces depending on the value that you currently have, and you're kind of managing it in your own way rather than having the program kind of do it for you.
I don't know why you'd want to do that. I think I would always want the program to do it for me.
I did it in program 4, I believe, for chapter 5's. But I did it in a way using the question mark and colon. but I was generating them based on, where, the one value was here, the other values over here, that type of thing. I was generating the spaces depending on the decimal places and things like that, to more of like move it and adjust it automatically, rather than just kind of have the printf trying to set it off a little bit. It would have like an offset. It looked kind of weird.
Okay, well, sounds like you've got something else figured out here, but I don't think it's part of what we want to do tonight. But if that works for you, that's cool.
All right.
Okay.
Could you go over that last line of code there? You've got it highlighted 15 to 25, and kind of how the computer is reading out the range there. So you have the %d \n, and looks like you're plugging the 15 into that format modifier, and then it also concatenates the int random integer, times 11, and how that kind of ranges between 15 to 25.
Yeah, the reason that comes from 15 to 25 is what this does. That's going to be from 0 to 10.
Correct.
Because of the int. Because we're casting it to an int, we'll lose the decimal part. So that'll be from 0 to 10. And if we add that onto the 15, that means we're going to be from 15 to 25. Right? We've got a minimum of 15. All of this is the argument for %d here.
Right.
That whole thing gets replaces the %d, whatever this evaluates to. But that evaluates to anything between 15 and 25. Every time we run it, we'll never get anything less than 15. We'll never get anything more than 25.
Okay, I understand.
Okay.
Can math.random generate 0, or does it always go to like 0.00001?
It can be 0.
It can be 0.
A moment ago, I had a 15 here actually. So it obviously, yeah.
Okay.
Okay. All right, let's take a look at the next one then, if you're good with that. Also covered in chapter 4, we have strings. Strings are covered in Java 4 and chapter 4. And here's the thing with strings. A string is an object type. It's a class. Notice the capital S on string. In Java, a string is a class. Classes have functions built into them. We call them methods. And in the case of strings, there are lots of them, lots of methods that you can use to manipulate or work with strings. So we're going to start with the string having a value of Java. James Goslin, the guy who invented Java, or credited with it at least. We can use the length method to see how many characters are in that name. We can also use the charat or carat method to see what the first element is in the string. Strings are indexed starting at 0. So the characters in a string are indexed starting at 0. So the first character in the string is going to be charat 0. The next one is charat 1, etc. So we'll run this one. And there's 13 characters in the name, James Gosling, counting the space. There's the J, that's charat 0. And is it lowercase? No. So the result of this is we're using the character class. We're embedding this inside of the is lowercase method. And so it comes out as false because, of course, it's a capital J. Now, there's some very interesting methods. Here's one called ends with. Does the string end with sling? Makes me think of those terrible commercials that are on TV. If we check that out, it does, of course. We get a true for that because Gosling does end with sling. Here's the contains. Is this sequence of characters inside the name? Yeah, well, yes, it is. So we get a true for that as well. Now, here we're setting up two variables, both with the value of Java. And we're using the equals operator here to test and see if they're the same, but that's not right for strings. Because strings are object types, what you're doing here is you're just actually looking at the same address in memory. Because what Java will do is if it has two strings with the same value, it will actually just store them once in memory and will reference them with two different values, lang1 and lang2. So all we're doing here is seeing if the addresses of the strings are equal. It doesn't really test the strings themselves. If you want to test a string for a particular value, you should use the dot equals or equals ignore case method, which is in chapter 4. Okay, there is a compare to method which you can also use. It'll return 0 if the two strings are equal. Now we're going to find that compare to will also return other values that we can use to sort strings, for example. Any question about that one? A lot of methods that are available. They're all in chapter 4. Actually, there's more in chapter 8, I think. We covered it again in chapter 8. All right, here's the second one. I'm going to create a string called bananas, a string called fruit with a value of bananas, I should say. And we're going to use the substring method. Substring has a couple of variations. If you use substring and follow it with a single index value, what you get is starting index at index 3 and from there to the end of the string. I'm going to run this one. So starting index 3 is actually the 4th character in right there. That's index 3. Remember, indexing starts at 0, 0, 1, 2, 3, and then just specifying substring 3 means go from there to the end of the string. So that's why we get this output down here. 2 to 6, you might think that goes from 2 to 6. Well, actually, it goes from 2 to 5. So that gives us nana. And 0, 3 gives us actually from 0 to 2, the first 3 characters. So we get the VAN there. So we can extract parts of a string with the substring method of class string. Here's an interesting one. If you want to locate where a particular string exists inside of a string, you can use index of. It'll report the starting index of what you're looking for. So the index of n, the first index of n is there. But there's also a last index of n, and the last index of n would be this one here, which is in fact a 4, index 4. Now, here's a string with a number inside of it, as you can see here. Well, we can't do mathematics with that. It's a string. But the capital I integer class can convert that into a number that we could do arithmetic with. We could convert it into an integer by using the parseInt method. Integer.parseInt will convert that into a number. The double class will convert a number with decimal places into a double. And what we're going to do here is we're going to assign, after we parse this string, we'll find the square root of it and print that out here with math.squirt, the math function. By the way, the math class, I should say, the math class has many functions. This are also in chapter 4, and this is the square root function. So if we check that out, it's 3.5. 3.5 is the square root of 12.25. And the president was over visiting the Prime Minister of England recently, and her official residence is 10 Downing Street. We just wanted to show you that you can concatenate strings together, and if you actually use an integer with the string, it concatenates okay. Any question about that one? Covered a lot.
Integers and parsing, and also double and parsing. Any of these parsings, they can return null sometimes. Will they stop in their tracks, or will they continue on, and you could do like an if statement to check if it's null?
Yeah, that's right. If they don't actually have a number in here, they're going to fail, right? Exactly. Yeah. Yeah, like you can't parse like a string,
Right.
for example. Yeah, a string that's got a name in it, for example, or an address or something. Watch this. Yeah, I'll just change the value of that string and run this again. Crashes. There's the number format exception. We can't convert that into a number because it's got the characters in it.
So I know you can catch that with a try and catch, but are you able to do an if num equals null? Will that actually get to that point, or will it just kind of stop where that exception comes in?
Well, the way to handle this is with the try-catch block, like
Okay.
you mentioned earlier.
Yeah, that's what I figured.
Okay. Let's carry on with this next one. Some more stuff about the math class that's in chapter 4. And this might help you with one of the assignments, one of the questions in your assignment where you have to work with the right angle triangle. Hopefully you know a little bit of trigonometry. If not, you can Google it, sine, cosine, tan, mean, and you can figure it out if you haven't taken trigonometry. But we can convert degrees into radians. We can convert radians into degrees, and we can get the trigonometric ratio for any angle in radians. We can also change any value back into whatever angle it might represent. So this particular program runs like this. Okay, so that's chapter 4. Any questions about any of this stuff? I know we're going awfully quickly, but what you should do, no, these are the ones that I made up, right? You should also work through the author's textbook examples too, right? You want to work through this zip as well. I just went through the second one. You should work through this one too as you're working through each chapter. Okay. All right, I'd like to go to the next module, which is about working with loops. And in that one, oh, there we go. Okay. If I scroll down, once again, we have a web page with some content in it. I'm going to open that up. And as before, we've got the textbook zipped examples, and I've made up some other ones to complement what's in the textbook. There's a document that you should keep handy. It's a Word document in which I tried to summarize some key points in the chapter. But I have downloaded this zip file, the second one, and I'd like to work through some of those with you. So I'll just collapse this project here, which I can do by right-clicking on it and selecting Close. And I'll open up this one, and we'll take a look at the examples that are in here. We've got 10 to take a look at here, so we're going to have to hustle. But this is all about loops. It's actually a fairly easy concept in Java, but you have to get used to the syntax. Every time you start a new language, you have to get used to the syntax. All right, so here we're going to start with the while loop. While loops use the while keyword, and then they have an expression inside parentheses, which if evaluates as true, will execute the code that's inside the loop. Now, in this particular case, I only have one statement inside the loop. Notice where that opening brace is. This is bad. We don't want you to do that. That's C style, right? Just to drive home that point. We want to open our loops on the same line as the while statement in this particular case. Now, a while loop might not run at all. And in this particular case, I don't think this loop runs. So I'm going to give it a run. And we will see that the entire loop here gets skipped. This doesn't get printed because this is false. 100 is not less than 100, it's equal to 100, so that's false, so the entire loop gets skipped. That's the thing about while loops, they might not ever execute. They're called pretest loops for that reason. If the pretest does not evaluate as true, the entire block inside the braces is skipped. Now here's another while loop. This time we're going to notice the expression this time is while none is greater than or equal to 0. Well, it starts off at 100, so that's going to definitely start. And what we're going to do is we're just going to print out a couple of asterisks in the value of num. We're going to print all in one line, though. Notice that's print instead of print line. And then we're going to subtract 20 from the value of num. And then the loop should cycle. Without this line, we would have an endless loop, right? And the program would eventually crash in Java. So we'll give it a run here. It's kind of silly, nonsensical output, but that's the output that's generated by this loop. And the final value of num is, as you can see, it's minus 20. It's not greater than or equal to 0 anymore. That's what made the loop stop, because this evaluated as false. And that stopped the loop. Okay, any question about that one? While loops. Let's take a look at number 2. Example number 2. This one uses a scanner. We're going to get input from the keyboard here. And what we're going to do is we're going to pose a question. We're going to ask the user to enter an integer that's a multiple of 11. And what we're going to do is we're going to use a loop to make the user keep entering values until the user complies with the request to enter a multiple of 11. So as you can see, we've created an instance of scanner here. By the way, we did show you folks how to create a scanner instance, right? Mm-hmm. If you did a shortcut for scanner, if you just type in scan and hit Control space. Oh, one's gone away. I don't have one here. I have one on my office at work, so my computer in my office. I'm going to reset that template up just to show you, because it's an important, nice skill to have. If I want to create a shortcut, like that SYSO is a shortcut for system.out.println, well, what I can do is I can select Window, Preferences, expand the Java, expand the editor, and there's something down here called templates. If I select that, here is a list of templates, which are shortcuts that we can use to enter lines of code. And as you can see, there's quite a few of them already developed for us. Well, we want to create a new one for scan. So I'm going to do that right now. I'm going to call it, the name for this one is going to be scan. What it's going to do, this is just going to be a description which will pop up when I hit Control spacebar. So we'll call this create new scanner instance, or a new scanner object. And the code is actually what we had back in our program back here, which would be scanner. Input is what the author uses, so I'll use the same thing. New scanner, and system.in is Java's name for the keyboard. System.out is the screen, by the way. That's why system.out.println outputs to the screen. Okay, so there it is. So I'm going to hit OK, apply and close. So now if I type scan here, Control spacebar, there it is. All I have to do is double click that or press enter. Now, as it happened, I'd already used one here, so I'm getting an error message now down below because I've redeclared a scanner object with the same name. But you'll notice that now I have import java.util.scanner. Here's a very important concept. When you first start up Eclipse, start up Java, there's a default package called java.lang that has all kinds of classes available for you. But not all classes are in there. Some classes are in other packages. And the scanner class, for example, is in the util package. So we have to import it. Just like in Python, if we wanted to use a module, we had to import the module. Well, in Java, we import classes from packages. And a good way to do that, by the way, is by using the source menu here. Anyway, we'll get rid of this one. Just wanted you to see that in case you hadn't seen it before. And now the error has gone away. We are getting the nag, though, that we've got a resource leak because we haven't closed that input. We'll do that. All right, so the prompt is to enter an integer that's a multiple of 11, and we're going to use input.nextInt for inputting an integer. And here's our loop. While the answer %11 does not equal 0, %11 means the remainder. So if the number we entered does not have a remainder of 0 when divided by 11, this loop is going to continue to cycle. And as you can see inside the loop, we once again ask the user to enter the value. So it'll keep running until the user does the right thing. So let's see what happens here. I'm actually going to start off by entering a number that is a multiple of 11. And you can see the entire loop gets skipped, right? The entire loop gets skipped because this evaluates as false. So output jumps down to here. If I run it again and I enter a bad value like 23, now the loop is running and I'm prompted now to enter another value. And this is going to continue to run until I enter a value that is a multiple of 11. Okay, so in this way you can force the user to, if you have a data input application, you want to make sure that the input meets a certain criterion. This might be one way you could do it. This is an example of a while loop. Hope you're okay with that one. Let's take a look at number 3. What we're going to do here is we're going to nest loops. Loops inside loops is called nesting of loops. And what we've got here is we've got 2 while loops, one within another. This entire loop is inside the outer loop. And we've got a couple of variables here. We're going to output some stars to generate a triangle. Okay. And of course, if we change this number here, it'll change the size. I'll make that 15. I'll just get a bigger triangle. I'll get more rows. Okay. Anyway, it's just one of the things you can do with nested loops. Let's just take a look at number 4 here. Very often what you want to do with loops is you'll want to both count and accumulate. Very often you'll want to work through some numerical values. You'll want to add them all up. That's called accumulation. For that, you need an accumulator that starts with an initial value of 0. Sometimes you'll also want to count items. Well, then you need a counter. Counters should also be initialized to 0 and incremented by 1 each time you have discovered something that you want to count with the statement. So as you can see, we've got a scanner here again, and we're going to ask the user to enter a positive integer or 0 to quit. And we have a while loop here that's going to continue until the user enters a 0. As long as the user does not enter a 0, this loop will continue to cycle. So let's see what happens here. We'll give it a run. Okay, I'll try 4. I'll just try small numbers here. 4, 5, 6. Now I'll enter a 0. That should stop it. Notice that the count is correct. I've got 3 integers. Didn't count to 0. And it does add up to 15. 4 plus 5 plus 6 does add up to 15. So notice how the accumulation works, though. The accumulation goes up by the value of the variable. Counters increment by 1. Very important point about accumulators and counters. And they come up all the time. Hope you're okay with that. Any question? Just break in anytime now if you have a question about anything.
If you enter a negative here, what will happen?
A what?
If you enter a negative integer.
A negative integer?
For the input.
It'll keep running.
Okay.
Yeah. Now, if we wanted to not allow that, we could make this greater than 0, right? Right here, we'd make that greater than 0. Yeah, if I enter a negative, watch what happens. Okay, I'll try 12, 3, minus 12, and then a 0. Total is 3. Right? The plus 12 and minus 12 cancel each other out.
This is there's 3 integer.
That's true, isn't it? 3, 12, 3, and 12. That's 3 integers.
Oh, 0. Oh, yeah.
Yeah, the zero's not counted.
Oh, it quit. Yeah, yeah, yeah. Okay.
Okay.
Um,
Yeah, go ahead.
for the total plus equals num and the plus plus count, is the count variable, is that what is take? Is that counting however many integers that you put in so that it can produce out to 3 integers total 3, you know, so you have the code in there to total up the integers that are entered, but is the count that you have there counting how many times the user is inputting integers?
That's right. That's right. That's the count here. I guess that was a bad choice of me entering a 3 here. It's a bit confusing, perhaps. I'll try this again. I'll try 10, 6, 4, 0. I entered just 3, and they add up to 20. But I could enter 100 with this program, right? I could just add up as many numbers as I want. And of course, since I have the count and the total, I could find the average. You could do lots of things with this. Okay, good questions. Here's number 5. Take a look at number 5 here. Now we're going to look at a different type of loop. Instead of a while loop, we can also have do while loops. Do while loops are a bit unusual looking. They look kind of weird. They start with the keyword do and then open a brace right away. The while is after the closing brace and requires a semicolon at the end, by the way. So these loops will always run this code at least once because the test is at the end of the block. It's called a post-test loop. It always runs at least once because the conditional expression is at the end of the structure. So once again, we're going to use an accumulator and a counter here, and we're going to basically run the same program as before. But this time I am going to use greater than 0. So I've changed this a little bit here. Okay, I've changed this a little bit. This actually, it will quit with a 0, I suppose, but it also will quit with a negative number. This one will, I believe. Let's try it. Okay, we'll try 2, 3, 0. Yeah, that works out okay. We didn't actually use the counter. Actually, we don't have a counter, do we? This time we're just totaling. We didn't count this time, but we did get the right total of 5. Let's see what happens if we enter 3, 4, minus 2, and that stopped it, and we have a total of 5. 3 plus 4 is 7, and then take the minus 2 brings it back to 5. But because the condition is now false, because it's not greater than 0, that stops the loop.
Could you possibly add some condition before and some condition after? Or do you have to choose one?
Not sure what you mean.
Like for example, you add like a counter, but like after the while instead of before it.
Well, it is after the while.
No, like if you add in some other condition that's after under it.
Oh, I see. This could be a more complex condition. Like, yeah, you could say and num percent 2 does not equal 0. In other words, you don't want to allow an even number.
But would you be able to input anything below the line, like at line 23? Like a statement?
Sure, yeah, but it's not, won't be in the loop.
Oh, it won't? Okay.
The loop actually ends here. That's the closing brace.
Okay.
Yeah. Okay, let's take a look. I'm going to take that back to where it was because I'm going to upload these. I've made one or two changes here, so I want to re-upload this file to the page. Now, Other type of loop, for loops. For loops, very common, my personal favorite, by the way. For loops are great because they're useful when you know exactly how many iterations you want the loop to go through. Iteration is the fancy word for cycle. And because of that word iteration, it's customary to use the letter I as a loop control variable, although you could use anything at all. But I think you're going to see I used almost always in Java textbooks. So here's the way the for loop works. You have three parts separated by two semicolons. There's a semicolon there, and there's a semicolon here. So the way it works is you have the declaration of your loop control variable here. Then here's the condition that the loop is going to continue running for. And here is a modifier that's going to change the value of the loop control variable so that the loop will eventually end. So that's the great thing about for loops. You won't get endless loops as a rule with for loops unless you do something special to make that happen. So what this is going to do is, you can see we're going to go from 0 up to 9. We won't ever get to 10, I guess, because of the less than here. And we're going to output them all on one line. So I'll just run this. We get from 0 up to 9 on one line with that for loop. This time, you notice we declared the I inside the loop. Well, that I is available only inside the loop. If I were to comment this line out here, this line here's got a comment on it. If I try to print the value of I at this point in the program, Eclipse complains, doesn't know anything about I, because I was declared inside here. It's not available outside the loop. Okay? When you declare it that way. If you declare the variable inside the loop, it's not available. However, you can, if you want, or if you need to, you can declare the variable before the loop starts. Just don't redeclare it when you start the loop here. So this will output the very same thing. This I is going to be available inside and outside the loop because it was declared outside the loop. So if we run that again, well, actually, no need to run it again. Here's the output from that second loop here. And the value of I after this loop is 10, because when it gets to 10, that makes this condition false, and that's what stops the loop. And here's an example. Loops don't have to always be ascending. Here's a descending loop. We're going to let num start with the value of 0, continue while it's greater than or equal to 0. So that means it's going to include the 0. And what we're going to do is we're going to modify it by subtracting 10 in each iteration. So when we run that, this is what we get down here. For loops are a lot of fun. You can do some really interesting things with them. Let's see what we got here. Here's an example. You can generate a lot of output with not much code. That's why for loops, that's why loops are great. You can generate all kinds of output with just a little bit of code. You notice we've got I, and then I times I, and then I times I times I. So we're getting I, the square of I in the cubic line. Let's take a look at number 8 here quickly. We're running out of time, unfortunately. Here we have nested loops, a for loop inside of a for loop. This for loop is nested inside the outer for loop. So I'm going to run this one. And it's another way of getting a triangle like we did back in using the while loops.
Quick question about for loops.
Yes.
So when it comes to for loops, when it comes to the origin of it, the third modifier, why is there a third modifier? Because yeah, because technically, if you were to subtract 1 from the first, the initial I, and then were to add to the I beforehand, you would essentially make the loop faster. So, for example, using 2 of those colons there and completely ignoring the third value.
What do you mean, taking this out?
Yeah, so if you take that out and then make I 0.
Where?
Same line, just it's the first initial.
Well, I made it 1.
Yeah, so if you make that 0 and then do plus plus I on the next section,
Oh, you mean inside the loop?
Yeah.
Oh, yeah. Well, I see what you're saying.
Well, not inside the loop, like in the same line of the for loop when it's first declared.
Okay. Now, you think that would run faster?
It does run faster because if you use system current milliseconds, it runs about 200. Not 200. It was a little bit less than that, but it runs a little bit faster and it gets through a bigger amount of iterations before the initial is.
Okay.
So
Well, that's all very interesting, but
yeah,
it's a little bit of a diversion, unfortunately, from what we're doing.
I gotcha.
This is the standard way. The standard way of using a for loop is you put a modifier here that makes the loop eventually stop. Right? You've got to get the value of I up to the value that's going to make it stop, or down to the value that's going to make it stop. Okay, let's have a look at this next one. Break and continue. The break keyword will immediately stop a loop. Continue will skip the rest of the loop and restart the next cycle, the next iteration. So in this particular case, I'm going to run it first. Here's the output that we get. We're going to be using a while loop, as you can see, starting with num having a value of 0. We're going to go up to 20, and we're going to include 20. We got less than or equal to 20. Each time through the loop, we're going to add 1. Well, here what we're looking for is a multiple of 3. So if we get a multiple of 3, we're not going to print anything out. We're going to actually restart the loop. That's what continue does. If we get a value of 17, we're going to stop the loop continuous completely. So that'll actually stop the loop. So as you can see, we don't get a 3, we don't get a 6, we don't get a 9, and we don't get a 12 or a 15, but when it gets up to 17, the loop stops and doesn't print it out. I mean, it's kind of a silly example in a way, but the whole point is break stops the loop, continue skips anything below that in the loop and restarts the loop up here again. Break and continue. One more. Example 10. And this is the one I wanted to get to when we were talking about format back in chapter 4 using printf. This will show you a nice way that you can print out nicely formatted tables with the decimal points all lining up. That's what this one's all about. Here we've got output that's showing the value of n from 1 to 16. We're going to get the square root, the square, and the cube. And you'll notice that the decimal places all line up very nicely. And you get that control by using printf and format specifiers that we have here. The minus 2d means left align it. So that's why the value here is right up against the margin. Percent 8.4f means printed in a field 8 characters wide with 4 decimal places. 10.4 means 10 characters wide with 4 decimal places. 12.4f means 12 characters wide with 4 decimal places. So that's the output that we've got here. And we're using map.how to get our squares and cubes. I think we're running out of time. We might even been cut off by Zoom, but I hope this helps. If you have any questions at all, any more questions we can try to help you with.
So for chapter 3,
yeah,
I didn't really understand, like I saw your comment, but I really don't understand the last, like the program for what they are looking for.
Program 4?
Yeah, for chapter 3.
Okay, let's see if I can get there. Hang on, we'll look that up for everybody. It's just don't understand what I'm trying to say.
Yeah.
That disappoints me because I understand what you're saying. I work pretty hard at trying to make it clear.
Well,
I feel badly. I'm sorry about that. Let's see if we can get to it. I'm trying to bring it up here, and I'll bring it onto the screen in just a second. Okay, here we go. And it was number 4, you said?
uh-huh.
Okay, so here it is here. Enter a day of week that consists of 6 characters.
Uh-huh.
Okay, well, that would be like Monday, Friday,
Yeah.
Sunday, right? The program should examine the input and respond positively or negatively. We want to use a switch, and we want to stack the cases as shown on page 101. The program should handle inputs that are not valid weekdays by reporting that as well. Okay, well,
Okay. Oof.
what I was referring to
Mhm.
there, if you take a look at page 101 in the ebook, I'll bring it up. Here's page 101, and here you see some cases being stacked. By stacking, what that means is this particular program, we're switching on a number, an integer value, and we're going to get the same result for 1, 2, 3, 4, and 5 because of this.
Oh, so you want me to align like Monday, Friday, and like Sunday together, and then break it at Sunday?
Yeah, that's right. You're going to have case. Well, I guess I'm giving away the answer, but I don't mind. So here, your first case would be case. It doesn't matter which one is first. The case Monday, case Friday, case Sunday. Then your output would be.
Okay. Okay, so that's what you
would
mean.
output a correct response, right?
Uh-huh.
And then you could follow that with case for every other day of the week and say, no, that's not a 7-day, a 6-day weekday. And then in your default case, which is not shown here, you would say that's not a valid day.
Yeah, yeah.
Good
I got
idea
the
that you
default.
have the default case in there. I think you get the idea of a default case over here. Yeah, like if none of the cases is applicable, the default case can be used to generate some output too.
Yeah, and I also didn't put Saturday or Sunday because like I was too focused on like weekdays.
Whenever I did this program yesterday,
Yeah, yesterday as well.
Whenever I was asking the user for input, I kind of like, it's a long line of characters, and I've kind of have my case numbers matched in the line of text that's introduced to the user that they are reading can kind of choose from. So it kind of gives the user, a logical choice.
Okay, but wait a minute. You're modifying the problem, okay? And you shouldn't do that. It sounds like you have some Java knowledge and you sound like a really creative person, which is wonderful. But at this point, we want you to follow the directions.
Now, also, I thought about it. The user might input like different capitalization, so I changed my like the variable into like to lowercase, so like everything to lowercase.
That's very cool. That's very cool. Some people do that.
Okay. That's okay though.
That's quite all right. You could change it to all lowercase or all uppercase because, of course, unfortunately, some people enter like Sunday without a capital. That would not occur to me. I guess that comes out of the texting generation, which I'm in now, but it's not the only way that I learned to write the day Sunday. I always capitalized it. And I always use the capital I to refer to myself when I'm texting as well. I don't use lowercase i's. Unfortunately, that's led to too many of our students. Pardon me for preaching here for a minute, but I sure hope in writing your letters and so on, if you're writing anything that's official, that you want to make sure that you use good grammar, good spelling, and proper punctuation. Yeah, like to me, if you want to write Monday, it's capital MONDAY, not lowercase. But that's a very, you can make your program user-friendly, I suppose, by changing the case before you do the switch. Yeah.
Got it.
When it comes to strings, there is a word utils, isn't there? There's a class that you can capitalize the first letter to make it a little bit user-friendly? Or is that in like a Maven project?
Yeah, there you go again. So you're talking about stuff that's not in the course, okay? Yeah, I'm sorry. Yeah. No, you could class string does not, to my knowledge, have anything in uppercase, the first character.
Gotcha.
Yeah. But you could do it by replacing it you could do it with the replace method. Replace the first character. Any other questions, folks?
Nope.
Okay. Well, I guess we're done. I'm not even sure if this last part was recorded or not. So thank you very much for attending. I hope you found it helpful. We'll do this every week. I guess next week we're going to do methods, very important chapter. I believe it's methods next week. Just check that out. Yeah, very important chapter next week. We're going to write our own custom methods, like writing our own functions. All right, so I'm going to sign out now. Have a good week.
Take care. Thank you.
Brad out. Bye-bye.